Okay, and now we're going to be doing the last 2 pages. We've got the area of the polygon. So this is using sine, since we have a side, 2 sides and the angle between. Area is 1/2 one side times the other times the sine of that angle between. So we have 1/2, one side is 8, one side is 5, and then the sine of the angle between is 52. So 1/2 of 8 is 4, 4 times 5 is 20. So we're going to do 20 sine 52. 20 sine 52 is 15.76, nearest tenth, 15.8 inches squared. Alright, now, next one, find the area of a regular pentagon with a radius of 4. Alright, this isn't giving you a picture of the pentagon. Radius is from the center to the edge. So again, we pull out a triangle. That is 4. Our angle is 360 divided by 5, and that divided by 2, which makes 10. So 360 divided by 10 gives us 36-degree angle at the top. Alright, to find our opposite side and this is the apothem. First we'll find the apothem. That's adjacent and hypotenuse, so it's cosine. We're going to do 1/2 perimeter times apothem. Apothem is equal to 4 cosine 36, which is 3.24. We'll do 2 decimals, and then by the time we're done, you'll be able to figure out which answer you have to pick. So we'll just keep it to 2. Okay, 3.24 is our apothem. Okay, now we need to figure out our side length, so we need the opposite. The opposite does the same equation, only with sine. And then we're going to have to multiply that by 2 to get the side length, because this is just half a side. So 4 sine 36, 2.35. But then we're going to multiply that times 2, and we get 4.7. Never mind that. Times 2 equals 4.7. Alright, now we have to multiply that to get the perimeter times 5. Is 23.5. So the perimeter was 23.5. Okay, 23.5. So our area is 1/2 times 23.5 times 3.24, sorry. Alright, so 23.5 times 3.24 divide 2. 38.07 is what we end up with. Centimeters squared. There we go. Okay, find the measure for the arc ADB. So ADB. Alright, so it's really just going to be 360 minus 40. So that's 320 degrees. Alright, to find the arc length, we use the percentage of a circle times its circumference. The circumference of a circle is 2 pi r. R is 5, so that's 10 pi. And then we're going to multiply that by the fraction of a circle. It's 135 divided by 360 would give us the fraction of the circle. Okay, so that's what we're going to do. 135 divide 360. We get 0.375 times 10 pi. Oh, nope. Just times 10. It says leave the answer in terms of pi. So 3.75 pi. Alright, back up to this sector. Area, so we find the area of the whole circle, and that's whatever portion that is. And we know that from its angle. This would be, the full line would be 180, so this is going to be 105. So the portion of the circle is 105 over 360. And now the area of the circle is pi r squared. R is 8. So we have 8 squared, so 64 pi. That's what we're going to put in our calculators. 105 divide 360 times 65 pi. 59.56. And it's meters squared. I'm just checking what I put in my calculator. Yep, that worked out. Okay. Alright, find the area of the shaded region. Well, we've got a parallelogram with a circle. So we're going to take the parallelogram, subtract the circle. The parallelogram, this one whole side is 6 meters. So it's 6 times 4. Well, that's 24. So we have 24 meters squared minus the area of the circle, pi r squared. Looks like our diameter is 4, so our radius is 2. So we have pi r squared, which is 4 pi. But since it wants it in terms of pi, I can't do anything with this. So I am basically just done. 24 minus 4 pi. I'm just checking my numbers. Yep. Okay. Verify Euler's formula. Euler's formula, if you recall, was faces plus vertices equals edges plus 2. So how many faces do we have? We have 1, 2, 3, 4, and 1, 2, 3, 4 triangles. So that's 8 plus the base is 9. Vertices, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Edges, we have 4 around the base. 1, 2, 3, 4. We have 4 vertical. 1, 2, 3, 4. So that's 8. 4 at the top of the vertical. So that's 1, 2, 3, 4. That's now 12. 4 slanted, and that's 16. So 16 plus 2. Sure enough, 18 equals 18. There we go. Alright, cross-section of a cylinder that has been sliced, well, in this case, horizontally, but I think of it as vertically. Anyway, sliced this direction is going to be a rectangle. I can't do more than that since I have no measurements. So it's just rectangle. Alright, last page. I know, finally. Alright, so we have 2 volumes. The volume of the smaller is going to be 12 times 8 times 11. The volume of the larger is going to be 12 times 8 times 19. Oh, they only want the larger. What is the largest possible? So we're going to do this one. 12 times 8 times 19. 1824. Those were all in inches. So this is volume, so it's inches cubed. Alright, volume of this is going to be 1/3. 1/3 the area of the base times the vertical straight up height, and they also want surface area. Okay, so first volume, area of the base is 6 times 6, which is 36. The height we don't know yet. Height is this interior vertical right there. So we have to figure that out using some geometry here. Alright, we know that this is 8. We know this is 3 because it's half of one of the sides. Alright, so given that, I can find the other side. 8 squared is 64. This is just your Pythagorean theorem. Minus 9 is going to be 55. So, if we square root that, that's our vertical height. So this has square root 55 right there. So I can put this in my calculator, and that's going to give me my volume. So I have 6, well, I know it's 30, that's 36. I even know what it is divided by 3. Second, square root 55, and I get 88.994, so 89. Inches cubed. My surface area, on the other hand, I have 4 triangles, or sorry, yes, 4 triangles. First I have the base, which is 36, plus 4 triangles, 1/2 base times height, 6 times 8. 1/2 of 6 times 8 is 4 times 8, which is 24. So 4 times 24. 1/2 8 times 6 is 24. And then we have 4 of those. So the surface area is going to be 36 plus 4 times 24, which is 132. Yeah, that's what it is. There's no decimals. So this is inches squared. Okay. Let's rotate around the x-axis. It's going to create a cylinder like that. And let's see, you will need to know radius and height in order to find the right answer. So, in this case, the height is 4 and the radius is 3. Alright. Now we have 44, which is finding the sphere. That's not what I want. Hang on. Let's go back here. I don't know what I did, but whatever it was, let's undo it. How did I just suddenly lose my... Praise the Lord. Okay, it's back. Sorry, that freaked me out. Alright. 4/3 volume of a sphere is 4/3 pi r cubed. R is 5. So it's 4 thirds. 5 cubed is 125 pi. I don't know why it's flipping like that. Four times 125 times pi divided by 3 is 134.9. Oh, in terms of pi. Sorry, I need to get rid of that pi. My calculator. God, there we go. 45.76 with a bar. Pi. Feet cubed. Alright, we're going to go to the top of this one. We're finding the volume of a cone. Sorry, it takes a second. Trying to get the air conditioner to turn off, so I think that's part of that background noise that makes it hard to hear. Sorry. Alright, find the volume of a cone. Cone is 1/3. Area of the base is pi r squared. I don't know why it keeps flashing like that. And then times its height. Alright, the radius is 3, the height is 11. We have everything we need. So we're going to put this in our calculator as 3 squared is 9. 9 times 11, well, I know that's 99. Pi divide 3. It's exactly how I'm going to type that into my calculator. Although I'll go ahead and do 99 pi divide 3. I get 103.7. Centimeters cubed. Alright, we're getting there. 46. The two solids are similar. Find the ratio of the volume of the first figure to the volume of the second. This is volume. They're giving us lengths. So we're going to have to cube that ratio. First to the second, so it's going to be 36 over 60, which simplifies. They both have 6, and that takes it down to 6 over 10 and 2, so 3 over 5. So now we take 3 over 5 and we cube it. Okay, just lost everything. Wow, everything. Okay, that's alright. We had 3 over 5. Now it's not letting me do that. Well, 3 over 5 cubed is going to be 27 over 125. So that would be your answer. Kind of a script writing of numbers. That's weird. Okay. So let's see. Hopefully I can keep you while I do this. I'm going to close it out and bring it back. There we go. Let's bring it back. Okay, and we'll go back down to it, and hopefully that'll solve that problem. We can keep going. Yep, there it was. This was, what was it? 27. Okay, that's not needed to be writing, not doing that. So. Now it's doing this. That's very unique. Okay. Hang on, guys. I'm going to see what I can find. That is not what I want. Okay, let me see if... So far, so good. Yeah, okay, whatever. So let's see if this... Okay, that's not bringing it up. You get to hang in there for just a second while I try to get this figured out here. Practice final. Doing weird flashy things. Okay, I can do it on this, so we'll just do it on Word instead of PDF. I just have to get down here. Okay, we did that one. We're looking at... We're almost done. So, there we go. Find the measure of arc X. Well, since this is a diameter, we know that this is a 90-degree angle. If that's 90 and that's 50, that makes this angle 40. So if that's 40, it's half of the arc because it's an inscribed angle. So the makes X equal to 20 degrees. Alright, yay, got that one done. Just a couple more. Alright, this one we have that the multiple of 12x equals 6 times 3. Okay, so if we take x, 6 times 3 is 18, divide that by 12, we can simplify this. They both have 6's, 3 over 2. So x is 1.5. Alright, now we're looking, yeah, we're on the last two here. Alright, find x. Well, we know when we have a tangent and a secant, it's x squared equals 8 times 20, which is 160. Which would be, 40? No, it's 4 times 40, so it would be 4 root 10. So x is 4 root 10. Alright, find center and radius. Center, remember, don't forget to change the signs. So plus 2 gives me a minus 2, and a minus 4 gives me a positive 4. And the radius is the square root of the number it's equal to. So, root 25, so the radius is 5. So those would be your two answers for those two. Okay, and we're finally done. Alright.